Hey guys, welcome to your 12.7 notes on theoretical and experimental probability. By the end of the day, you'll be able to find theoretical and experimental probabilities. So let's get started right away. If you roll a 6-sided die, what are the possible outcomes? Well, you can either roll a 1, or a 2, or a 3, a 4, a 5, or a 6. So we say that our outcomes, we put them in curly braces, which look like this. By the way, if you need extra practice, do a C, and then make a point, and then make another C. And that's how you draw a curly brace. And then you make a backward C, and then another point, and then a backward C. And, oh wait, that's a frontward C, isn't it? No, it's a backward C. Alright, cool. Yay. And that's how you make curly braces. And if for now your curly braces just kind of look like that, or they kind of look like that, that's fine. Whatever. Okay, so we take all of our possible outcomes, we put them between curly braces and commas, and now we have what's called a sample space. It's a space where you put all your sample outcomes. It's a list of all the possible, outcomes you can have. So if you flip a coin, the sample space of a coin flip is heads or tails. So go ahead and roll your coin and figure out what you got. I got a 5. Boom. Okay. So an event, this brings us to our next definition. A sample space is the list of all possible outcomes. And then our next idea is an event. An event is any outcome or a group of outcomes. So an event could be rolling a 5, or rolling a 5 and rolling a 2, or something. Or flipping a coin and getting heads. Or drawing a card and getting the Ace of Hearts, or something. I guess I should say. Or getting the Ace of Hearts, which is red. Okay, cool. So here we're talking about theoretical or rather, we're going to talk about two things today. We're going to talk about theoretical probability, and we're going to talk about experimental probability way down here. And then we're done. Okay, so first, theoretical probability is what's going to happen in theory. What you expect to happen, what your calculations would say is going to happen. It's all about the theory, the idea of what's going to happen. Okay. So if all possible outcomes in a sample space are equally likely, you can find the theoretical probability of using an event by saying, let's say A is the event that we want. We say the probability of event A is the number of ways event A occurs over the total, I'm going to spell total wrong, the total number of possible outcomes. For example, if I want to find the probability of rolling heads, of flipping a coin, I can't roll heads, of flipping a coin and getting heads, well, there's only one way to flip and get heads, it's getting heads. And then finally, the total number of possible outcomes, you either get heads or tails, so the probability is 1/2. However, if I want to say the probability of drawing an ace from a deck of cards, there are 4 aces in a deck of cards, and there are 52 cards total, not including jokers. So that would be 4 over 52, which reduces to 1/13. So that's fun. Now, for some reason, this got to 2 pages, so we're just going to split like this. We write the probability of an event as a fraction. As you can see, I wrote fractions both times. So you can write as a fraction, as a decimal, or as a percent. Okay, so if you put these on actually I'll put these up here because I made my spacing funky anyway. So probability is always between two numbers. It's always going to be between 0 and 1, which means it's always going to either have, or it's going to be somewhere between 0% chance and 100% chance. It can be anywhere in between. If it's equally likely to go one way or the other, we say that has 0.5% chance, or 0.5 probability, which is a 50% chance. It can go anywhere in between. And as we go more towards 1, we say those are more certain. Those are more likely to occur. We say more certain. And then as we go towards 0, we say that is less certain. It's less likely to occur. If something has a 100% chance of happening, we say that that is certain. It has to happen. That is certain. For example, if you roll a 6-sided die, the probability that you roll a number less than 7 is certain because you have to roll something less than 7. There's only numbers 6 and lower. However, if something has a 0% chance, it has 0 probability, that is impossible. It cannot be done. Like, what's the probability if I flip a coin and I get a 5? You can't, because your options are heads or tails. So that's not going to happen. Okay, here we go. Find the probability of rolling a die and getting an even number. Well, remember, probability is the ways it can happen. Actually, I'm going to use this term. I'm going to say favorable, which means the thing that we want, over total. Okay? Probability is the favorable outcomes over the total outcomes. So let's count it up. Our sample space is all the ways that we can make this happen. So the sample space of rolling an even number is you can roll a 2, a 4, or a 6. Okay? So let's let E equal rolling an even number. Okay, I should be a doctor. Look at that messy handwriting. So we say the probability of E is the number of favorable outcomes, which is 3, over the total number of outcomes, which is 6. It's a 6-sided die. We have 6 options. That will reduce to 1/2. Done. If you prefer and you want to say, that has a probability of 0.5. Done. That's great too. I feel like the most common though is to say percent, 50% probability. Ta-da! Okay, cool. That's fun. Now, go ahead and pause the video and calculate the probability of randomly picking a planet in our solar system closer to the sun than the Earth is. That's not closer to the sun than it is to the Earth. Closer to the sun than the Earth is to the sun. Ready? Your probability should have come out to 25%. This is because we have 8 planets, and the ones that are closer to the sun than Earth is Mercury and Venus. Okay, so the probability then is 2 over the 8 total planets, Pluto, which is 1/4, which is 25%. Alright, the complement is different from compliment with an I, which is when you say something nice to somebody, which you should do, and that is a good thing to do. However, if you have complement with an E, that's a not thing. That's when something does not happen. So we say the complement, guys, I'm not going to rewrite it. The complement of an event is all the outcomes in the sample space that are not in the event. So if E is rolling an even number from our previous example, then we say E not, it's got that fancy little hat on, okay, right? That's the probability of not rolling an even number. Yay. Okay, right. So the even numbers in this case, the sample space would have been 2, 4, 6, but the sample space for E naught is 1, 3, and 5. And we always say that the probability of an event plus the probability of its complement is always equal to 1. Why does this happen? Well, let's go back to our little scale up here. And if something has a 50% probability, then it not happening also has a 50% probability. Cool. But if something has a 30% probability of happening, then it either happens or it doesn't happen. And so that'll be a 70%, which adds up to 1. So it's either yes or no, and then boom, adds up to 1. Okay. So again, with the weird, I think something just went weird when I made this, because, oh well. All right, 50 participants are randomly given a beverage to sample. There are 20 samples of Pepsi, 10 samples of Coke, 10 samples of root beer, and 10 samples of Sprite. What's the probability of a participant not getting Pepsi? Well, you guys, we could find out, okay, here's Pepsi. Wait, color tag. There's Pepsi. That's going to be our favorable outcome. Okay, cool. And then we have a whole bunch of other options. 10 of Coke, 10 of root beer, 10 of Sprite. And then we'll have to figure out what is not Pepsi and then add them all up and then subtract them from 50. You guys, that's so much work. There must be a faster way. Okay, so the probability of a participant not getting Pepsi, all we're going to do is we're going to find the probability of Pepsi, which is 20 over 50, which is 2/5, which is 40%. And then we find the complement. What is not that? Well, that's 1 minus 40%, which is 60%. And that to me was much faster. Yay! Also, if you wanted to do like 0.6 or 3/5, I will accept all of those. That's great. Okay, so that's all theoretical. That's all the ideas. That's what we would expect to happen. This is a stark contrast from experimental probability. Experimental probability is what you get if you were to run an experiment and what would actually happen in your experiment. Okay, so it's what happens when you actually do the thing. Experimental probabilities based on data collected from repeated trials. So how you calculate experimental probability is you say it's the number of occurrences, how many times the thing happened. Please don't judge my spelling. I'm not sure if this is right. All over the total number of trials. Okay. For example, after receiving a whole bunch of complaints, a skateboard manufacturer inspects 1,000 skateboards at random. He finds no defects in 992 skateboards. What's the probability that a skateboard selected at random has no defects? So, as we're looking for no defects, so the number of occurrences that happened was 992, and the total numbers he tried was 1,000. He tried 1,000 times. So that comes up to 99.2%. Cool. Now, what happens? What if we wanted to calculate the possibility of getting a skateboard with a defect? Then we would want to find the complement. So if we made this, I don't know, let's say defect testing. So the probability of getting a defectless skateboard is 99.2%. Okay, now let's calculate the complement. The probability of getting a defected one is simply just going to be 100% minus 99.2%, which is 0.8 which is not a lot, but probably higher than you would want as a skateboard manufacturer. Okay. Summary, experimental is what actually happens. And where is it? Theoretical is what you would expect to happen. So we're going to do an activity about that in class, and I'm super excited. Anyway, have lots of fun on your homework because I'm certain that you will.